All right. The first one. Your goal is always to look, is there anything common between both pieces? Before you do anything ever, you should always look, is there anything common to both pieces? Here, the 6a squared is common to both. We're going to take that out, and we're going to get a squared plus 3. Uh-oh.
So that's not right because it's not completely simplified?
The 6 is common to both. Now, if you just take out, say, a 3, and you leave, or 3a squared, and you leave 2a squared plus 6. 2 and 6 still share a common factor, so that's not right. Okay, you have to ultimately get down. What some people say is, but if I multiply this out, I get back to the original, that's fine, but you haven't factored completely. And you got to factor completely. It's okay. All right. What about this one? This one requires you to if your phone is ringing, please turn it off. Thank you. This requires you to thank you. Factor by grouping. So you're going to group the first two. You're going to group the second two. Here you're going to get x squared. Take out the x squared. What do you have left? X plus 6. Here you're going to take out the 4. It's common to both. What are you going to have left? X plus 6. Now, as you look at this and this are the same. So you can factor that out. And this is called factor by grouping. X plus 6, x squared plus 4.
And then you just take the 2 in front and put it as a group.
These two pieces here, this piece and this piece, then go together in one group. Okay. Yes?
I kind of factored a little bit differently, but like I factored like the first and the third and the second and the fourth.
Same thing.
Yeah,
if it factors, it generally will work.
I was gonna say 'cause in the book a lot of it was like that, like first and the third.
Yeah, it's fine. What's that? Which arrow? These arrows here? Okay, here. All right, so look, if I take the x plus 6 out, what am I left with? And that's what you see here. Right? And so that piece came out. They combine together when they come out. Just like here, the 6a squared is common to both, but I only write it one time. You see what I'm saying? Yes, 6a squared is in both of these, but I only write it one time when I pull it out. All right. Hey, did you get that one right? Ooh. Who remembers how to factor a trinomial? This is kind of a review from a previous discussion from somewhere else. Brett, what were you supposed to do? Do you remember?
Well, I don't think you can factor anything out.
Bless me. Thank you. No, you want to look at all three pieces to see if there's anything common to all of them. There isn't. So now we're down to having to go like this, right?
Yeah. I think you just want to keep switching the numbers until they work.
Okay. So how do you go about doing this? It's up to you. How you want to go about doing this? You know, you're looking for factors of 18, which are 6 and 3, 2 and 9, 1 and 18, right? You're looking at factors of 12, which are 1 and 12, 2 and 6, 3 and 4. And you kind of have to pair them around, multiplying them, adding them, subtracting them until you finally get the right answer. Okay, there's no good way to do it, really. It's just kind of a...
So you just want like a common number between them both?
Well, let's just plug in 6 and 3. We'll start with that. So 6x and 3x. And let's try... for example, 2 and 9. Now, we know that this is not going to work, and I'll explain to you why I know that's not going to work in a second. Okay, yes?
Oh, sorry. The XY, I mean, do you multiply 19 do you multiply the 19 to the X and the Y, or is it XY?
It's 19 times x and y, but the xy is of little significance. So, here, 6x times 3x gives me 18x squared. 2y minus 9y gives me, wait, I'm sorry, and 6. This needs to be a 6. 2y and 6y give me 12y squared. This is 18x squared. So those two pieces are right. But how do I know if the middle term works? How do I check that? You got a FOIL, right? So you got to do inside and then outside, right? So 6x minus 6y is minus 36xy plus 6xy. We're looking to see if we get negative 19. Do we get negative 19? So what do we know? This combination of numbers does not work. Does everyone understand that? Now, this is where things can get a little bit messy as you have to start this process of redoing it all over again. But let me interject something for you that is of massive significance once you see it. Okay. And that is simply this. This is 6x and 3x, right? 6x and 3x cannot be the right answer. I don't think anybody recognizes why not. And I want to show you why not. No, not necessarily. What factors? This 3 and this 6 would factor, yes? So that cannot be right. Does everybody understand that? That 3 and that 6 cannot sit side by side. Okay? And so what happens is people will say, well, that's fine. Switch these around. Well, is it okay to put the 6 here and the 2 here? Why not? Because now this 6 and this 6 factor. Does everybody agree with that? And so if you say to yourself, well, I can't use 6 and 2, I have to use 3 and 4. Well, can we use 3 and 4? Can I put a 3 here? Nope, because the 3 and 3 would be common, right? Can I put the 3 here? I cannot put 3 there either, right? And likewise, I can't use 12 and 1 because 12 there and 1 there would be a problem as well. Does everybody understand that? So at that point, I know that 3, 6 cannot work. That this cannot be a 6 and this cannot be a 3. So let's try 2x and 9x. Now let's try 3 and 4. I'll put the 3 here and the 4 here. Okay. Why? Well, would you ever want to put the 4 next to the 2? Why? Because they have common factors. Everybody see that? You never want to stick common factors side by side. That's a huge, huge point. Okay, let's see if this works. Negative 8xy plus 27xy. If I subtract those, what do I get? I get positive 19, right? What do I want? So what do I got to do? Switch the signs. And your answer ultimately should look like this. 2x minus 3y, 9x plus 4y. And that is your final answer. Is that what you put? So now you're up to 2 points. Oh, wait, no. No. You're up to 1 because you missed 1 already. So now you're at minus 1. Or you got minus 1, so you got plus 1. All right, what's the next one? How many of you recognize that as a difference of 2 squares? Brett, you remember the difference of 2 squares? You remember the difference of 2 squares? Back in the day, it would look like this. A squared minus B squared equals A plus B, A minus B. That's what the difference of 2 squares would have looked like if you saw it originally. Okay? So, that's what you have here. Now, Brent, what was the first one you always had to do?
You have to see what you have in common. Or in this case, I think you could divide, or you could factor a 4 out.
You can factor a 4 out. And you'd be left with A squared minus
Negative 25, and then you could factor that farther.
and then this is 4A plus 5, A minus 5. And now you're at 0 points. Now, if some of you would have gone into your blank and you would have said 2A plus 10, 2A minus 10, what should you notice? That the 2 and the 10 have a common factor, and that can never be right. Does everybody see that? That's a little check for yourself. When you get done, if you see the parentheses and you got common factors in there, that's guaranteed to be wrong. Okay? And this is all about learning. I think sometimes during the learning process we get caught up in the results. Don't do that. Okay. Okay. All right. Let me pause here. I want to pause here. So these were 4 questions that we added as extra practice. So if you're watching at home, here are the 4 problems that I added. You can just press pause right now and write them all down. And I'm going to work them out. Common denominator between these 3. What number goes to both of those? 7. What letter is common to both of them? X squared and y squared. You always choose the smaller of the 2 exponents if you see them. Choose the smallest exponent. Now, what are you left with? If we take the 7 out, that 7's gone, right? Take out the x squared, that x squared's gone. Take out 2 of the y's, you only had 3 of them, so what are you left with? Y. Minus, if you take out 7, you have 3. You had x to the 3rd, you took out 2 of them. You have 1x left over, and the y squared closes up. Any questions on that? Everybody able to get it? straight? All right, number 2. What was common to both of these? Judy, what was common to both of these two on the second one here? Yes, just the 3. We have x squared minus 9y squared. Now, can we continue? Why?
Because we have the variables are not single.
Okay, so we have the difference of 2 squares here, so we're going to get 3x minus 3y, x plus 3y, and we're done.
What was that again? Why did you have to?
This is a perfect square, and so is this. This is the difference of 2 squares. Why? The x is the problem? Oh. All right, number 3. What did we get? Nico, what'd you get?
Hard.
It's hard?
Don't you have to find something that is equal, two factors that give you 6 that give you 11? No. Okay, then never mind.
Let me just repeat that for the people listening at home, and I won't call you by name because it's a very common way that's taught in the previous courses. A lot of people use this idea. What multiplies to give me 6 and adds to give me 11? And the problem is, in the previous course, all your problems look like this. X squared plus 10x plus 16. You didn't have a number there. Okay? And so you got into this really bad habit of going, what multiplies to give me 16 and adds to give me 10? And then you go x plus 8, x plus 2. Good. And to a point that you actually got to where you didn't even check it. You just wrote down the answer and you're like, give myself a star, baby. Got that one right. Very bad habits to get into. Okay? And I'd like to know who your teacher was, and I'd go yell at him. Okay? In a way that only I can yell at people sometimes. All right? Because what happens is when you come to this course and this number in front of the x squared is no longer a 1, it's something else, that system fails miserably. Okay? And that is like the worst thing ever. Okay? Kind of like, when you're a kid and you can eat whatever you want to, and then you get older and you realize that system sucks. Happens to me daily. 3x and x. And then we need factors of 6, right? So that's 2 and 3 or 1 and 6. Now, here's the rule that I tend to tell people. Use the numbers closest together, 2 and 3 being closer together on number line than 1 and 6. These are both pluses because this is a plus and this is a plus. Okay, this plus means these two signs are the same. This plus here. This plus here tells me that these two signs are the same. Okay, and they're the same as the one that came before it. So they're the same as this one. All right? Now, we got to put the 2 and the 3. Should I put the 3 here and the 2 here? Why? If more importantly than it won't be right, because that's kind of a finalistic way to look at it. You ought to know it's not right because why? You cannot have two common factors side by side. That will never work. It doesn't work on Wednesdays. It won't work on Thursdays. And it damn sure won't work if you try it on Saturday. Okay? It does not work. It cannot work. Bad, bad idea. So let's put the 3 here and the 2 here. Now let's see if that works. 3 times 3 is 9x. 2 times x is 2x. We add them together, we get 11x. Bada bing, bada boom. Okay. Our last one. What did you get? This is, I cringe to use the word trick question, but this one's kind of setting you up to send you down the wrong path. What's the answer? What do we write?
2x plus 11.
If you say 2x plus 11 and what? 2x minus 11. Using something very similar to what we saw here, right? Or what we saw here. If you do that, you will get a negative 121, not a positive 121. And so what most people say is, well, fine, screw it, make that plus. The problem with doing that is then this middle term won't cancel out. You end up getting 22x plus 22x ends up being 44x. And I've actually had a student go like this. Well, then hell, don't do that. Make this one a minus. Well, now you're right back in the same place you just were. Okay? So the answer for this question, unfortunately, prime.
That means that is good. We have 1 point.
Oh, it does mean that.
We're gonna do the last problem on Monday.
There's a reason why I'm holding off on the last one.
On mine.
Number 5. Number 5 is not prime.
1.
We have negative
2x plus 5 cubed.
No, you had 0. Yes, technically you'd be at negative 1, but I will never take you negative, so you're just at 0. The answer for this is 2x plus 5 because it's cubed. So 2x cubed is 8x cubed. Now you've never seen this before, so the only way you ever would have gotten this one right would be to say, "Oh, I've seen it in the book somewhere," and that's probably not super likely. So it's 2x plus 5. You write down the 2 pieces that you started with, 2x and 5. And then the way I teach people to do it is to make an M. Okay, so if you just make an M, it'll look like this. Okay, and you're going to multiply all the sides of the M. So this one is 2x times 2x. This one is 2x times 5. This one is 5 times 5. Okay, 2x times 2x is 4x squared. 2x times 5 is minus 10x. 5 times 5 is. Okay. So the answer is 2x plus 5, then 4x squared minus 10x plus 25. Something that you should note is that there's an acronym for this. It's called SOAP. Same, opposite, always positive. Okay. It's the same as the sign in the original problem. Then it's the opposite sign. Then it's always positive.
I just put. Say that again.
This sign here is the same as the one in the problem. Okay? This sign here is opposite the one that's in the problem or the ones you have here. It doesn't matter. That last sign is always positive. So, okay? Again, if y'all looked at that and you thought to yourself, man, I never would have put that damn thing. Yeah, of course you wouldn't have. If I hadn't shown it to you, no one ever puts it. Okay? I'm reminded of, let's see if my man back there's got it. He says it's 2x minus 5y, then 4x squared plus 10xy plus 25y squared. The first thing you got to do is figure out what makes this a perfect cube. That's 2x. What makes this a perfect cube is 5y. Now, drop off the cubes and you have the first set of parentheses right there in front of you. 2x minus 5y is your very first set. You all see that? Now, again, I make this little m, which seems to work pretty good for most people. 2x times 2x, 2x times 5y, 5y times 5y. And what you get is 2x times 2x is 4x squared. Same, opposite. 2x times 5y is 10xy. Plus 5y times 5y is 25y squared. Nice job, Brent. Here you go. Give you 2 stars.
So you always find the number.
Always find the number first, yes. Other questions? Yes. You straight? Oh, you wanted to give me the answer for the next one. Yes. Okay. Let me press pause. Hold on. By the way, she was right, for those of you watching at home. All right. So, 27x cubed is 3x cubed. 1 is just 1 cubed, right? I think the 1 is what gets people kind of screwed up, because the 1's kind of like, what do I do with the 1? It's just 1. So, this is 3x plus 1. And then it's, make the m, right? 3x times 3x. 3x times 1. 1 times 1. 9x squared minus 3x plus 1. With that being said, I'm going to stop the video here.